Well, hello, ladies and gentlemen. This is the first and the second semester recordings for Algebra 2, and I wanted to welcome you all to my Algebra 2 class. This is the way I present the lessons to you, and then we will work some problems when we get into class today. So the lessons we're looking at today are in Unit 1, Lesson number 3. What we're taking up today is a concept called log division. Only we're going to use polynomials for it. And so that's going to be a little bit different than what you expect. Okay? Now, due dates. Due dates are every 28 days after a particular item has been closed, it will close and you cannot get into it again. So you need to get it done within that 28-day time frame. Don't delay. Zeros are the worst thing you can have in your grade book. Okay? So we need to make certain we're going to get those taken care of. Today we're going to take up the concept of polynomial long division. You've done long division before when you were in third grade and in fourth grade and things like that. And you've done this before. It's not really that big a deal. You took 75 and you divided it by 3. And 3 goes into 7. You determine how many times 3 goes into 7. And you say, oh, it goes in there 2 times. And so you get a 6 there. And then you subtract. You get 15. And 3 goes into 15 5 times. This is your divisor, this is your dividend, and this is your quotient up here. So we're doing the same thing with polynomials. Let me just give you an example of what it's like. X squared minus 6x minus 27, and we're dividing that by x plus 3. Well, I know that if I multiply x times x, I'm going to get x squared. So I'm just going to multiply that, and I'm going to get x squared plus 3x. And I'm going to subtract this. Well, subtracting that is going to give me 0. And negative 6x minus 3x is going to give me a minus 9x. Well, what do I got to multiply by to get rid of the minus 9? Well, that'd be minus 9, wouldn't it? Minus 9 times x gives me minus 9x. And minus 9 times 3 gives me a negative 27. Oh, I forgot to bring down my negative 27. Okay? So being those are the same, my difference is going to be 0, so that's going to be my answer in long division. And it just was a matter of knowing what to multiply it by to be able to get the same value, so that when it subtracts, it disappears. Okay? You're just going to repeat the process. Divide, multiply, and subtract. There's until no more division can be made. You're just going to keep doing it over and over again, okay? So here's another one. Let me show you how it works. 2x squared plus 13x minus x minus 4 divided by 2x minus 1. Well, it's going to take an x to get 2x squared minus 1x. I'm going to subtract these things. When I subtract this quantity here, 2x squared minus 2x squared is going to be 0. 13 minus a negative 1x is going to be 14x. I'm going to bring down my 4, minus 4. Okay? So let's see here. What do I have to multiply 2x by to get 14x? That would be a 7. If I multiply by 7, I get 14x minus 7. So I'm going to subtract this, and I'm going to get 0 here, and that's going to become a plus sign. Why? Because that minus is the entire thing. So it becomes a plus sign, and I will wind up with 3 as my answer. So what did I wind up with? I wound up with x plus 7 and a remainder of 3, or a fraction, 3 over 2x minus 1. So my answer in this situation would be x plus 7 plus 3 divided by 3 divided by 2x minus 1. Okay? Let's do look at this, the way it's, the terms here that are involved. You've got your divisor. You've got your quotient. And your quotient up here, and you get your dividend here. You're going to multiply this divisor by whatever it takes to get rid of this 2x squared. Well, that'd be a 2. That'd be an x. X times 2x gives you 2x squared. X times -1 gives you -1. You subtract it, this whole thing, so that turns to a positive, becomes 14x minus 4. You're going to multiply by 7. It's going to be 14x minus 7. It's going to give you a remainder of 3. That becomes your fraction, the numerator of your fraction. Okay? So there's a couple different ways we could express that. I mean, you could have said that is with a remainder of 3, or you could have said it is with a fraction at the end of it here. Okay? You do the same thing with polynomials. You either say it's got a remainder of 3, or you could say that it's 3 divided by 2x minus 1. Okay? So let's look what happens when we divide a polynomial by a polynomial. I'm going to do it one more time. 2x to the 4th minus 4x. Whoops, I want to get them in the right order there. I don't want to do them in the wrong order. Okay? There is a missing term there. There's no x cubed. And so what I want to do is I want to say minus 0x cubed plus 7x squared minus 4x plus 1, and I'm going to divide that by x plus 1. And the reason I had to make certain I had this 0x in here, okay, I got to have all the terms, 4th, 3rd, 2nd, 1st, and 0th, okay? So I'm going to multiply this one times 2x cubed. Why? Because 2x cubed times x gives me 2x to the 4th. And I'm going to say plus 1x cubed. 2x cubed, because I'm multiplying that times 1. So when I subtract this, that goes to 0, and this becomes a minus 2x cubed plus 7x squared. So I'm going to have to multiply by minus 2x squared. Why? Because minus 2x squared times x gives me a minus 2x cubed. A minus 2 times 1 gives me a minus 2x squared. I'm going to subtract that. That's going to give me a 9x squared minus 4x. Well, that means I need to multiply the x by a positive 9x. 9x times x gives me 9x squared plus 9x. And when I subtract this whole thing, I'm going to get a minus 13x plus 1. So I'm going to multiply this times negative 13, be negative 13x minus 13. And when I subtract them, I'm going to get 14 as my remainder. So I would say remainder 14, or 14 over x plus 1. So the trick here is to make certain that you have all your terms and that you write them in order. Okay? It's like writing the hundredths and the tens and the ones. You got to make certain you write them in order that they need to be written by polynomial. Okay? Sometimes you're going to get zeros, sometimes you're going to get remainders. What do the zeros mean? Well, if you get a 0, okay, that 0 is a factor of the polynomial. So we can use division to determine whether a minus 2 is a factor of this. We can just do the factoring. A cubed minus 7a plus 6. And we can divide that by a minus 2. Well, since we have an a cubed, we need an a squared termed in there. right? So I'm going to say plus 0a squared, and I ran out of room. I didn't do it right. Let's make certain you have all your terms, and I didn't do it. Okay? So a cubed plus 0a squared minus 7a plus 6. So I'm going to multiply this one times a squared to give me the a cubed minus 2a squared. Okay? Subtract it, and I'm going to get a positive 2a squared minus 7a. I'm going to multiply it times a 2a, and I'll get a 2a squared minus 4a. Subtract this, and you'll get a 3a plus 6. And I multiply it by 3, gives us a 3a minus 6. Is that a 3a? That's a minus 3a, I'm sorry. So that needs to be a minus 3 there. So that'd be a minus 3, that'd be a plus 6. And that gives me a 0. So I get a 0 remainder. That 0 remainder tells me that this is a factor of this right here. And this is what I have left over. So then this could be, this one up here could be factored again to find all the factors. This remainder theorem is basically telling you when you do the division and you get a 0 remainder that you have a factor. Okay? Nothing new there at all. Okay? I'm not going to have a secret word at this point. I appreciate the fact that if you're in Algebra 2, anytime that you give me a call, or that you send me a K-mail, or you send me an instant message, make certain you tell me that you're in Algebra 2. If you don't tell me you're in Algebra 2, I have to go looking for you to try to answer your question. Sometimes I can answer the questions without having to find your name in the grade book, but there are times where I need to know what course you're in to be able to answer the question. So make certain you always tell me that you're in Algebra 2. I appreciate you being here, and I'll see you next lesson. Bye.